Good morning, everybody, and welcome to today's session. Thank you once again for joining us. A little nostalgic for me, the last of 6 sessions. So it's been a fun journey. I hope that those that have joined us the whole way have enjoyed it. Today we're going to. We've got, I think you can see on video, you can see we've got Gino and Johnny with us. Apologies from Chamath. There was a bit of a storm in Colombo last night, and so there's a power outage in his area. He'll perhaps try to join us if he gets power later. I think South Africans, maybe not usually due to storms. We've got our own version of storms over here, but we can relate to those kinds of challenges. So Gino and Johnny, unless Chamath gets to join us a little bit later. I just wanted to, let me just share my screen quickly. Second. Let's go with this. Gino, just wave if you can see my screen. Okay, cool. So just using our website to navigate this. This is the homepage. So either clicking on the events, or there's events over there, or you can just click down here. But just to recap on the journey to here, this by the way was last year's summit. So for those that didn't get to attend that, the content is available there. You scroll down here. So here's all the content in terms of the 3 episodes. So we started with the API management session, and these are all the videos. And if you click through to this, the presentations are behind this as well. The identity and access management presentation session. We just started. We put the full video of Tuesday's session up. I'm still going to split it out into the 3 separate presentations, and then put the actual slide decks behind that as well. So that should be up in the next day or so. So that's what I really wanted to show. And with that, then I think let's get over to a chat. What we're going to do is the deep dive that we did with Christoni on the API management session really turned into more of a demo that Christoni ran, and API Manager more lends itself to that. Then Johnny took us through sort of a quasi demo and sort of a self-led chat on his deep dive. And today we've tried to make it a bit more panel orientated. We were hoping to have Chamath with us, and like I said, he might still join. But with Johnny and Gino, I think they'll get the conversation going, but I'm really hoping that our audience is able to participate in a conversation. So the guys will share thinking. This is not like some kind of a right, wrong, know all the answers, expert kind of a thing. I almost thought about it a little bit like the concept of meetups, where people get together and are able to share ideas and thoughts. So think about it in that sort of a style, and contribute / ask questions, and thereby get as much value out of this as you possibly can. Okay, so with that, I'm going to ask Gino and Johnny to just enable their microphones, come off mute, and to get a chat going for us. All right, I'll stop sharing my screen.
Thank you very much, Steve. Yeah, so as Steve mentioned, this is just going to be a little campfire chat we're going to do, specifically around infrastructure as code. Of course, we are going to carry on kind of with a theme from Gino's chat on Tuesday with regard in the time context. But yeah, like Steve said, we would like to get a conversation going. So anyone in the chat, if you feel you've got a question or you just want to join the conversation, let us know. We'll enable your mics, and we're more than willing to answer your questions and actually start with that. I think, yeah, Gino, I think if you want to, you can kick us off. Gino just had some questions earlier on, well, between this session and Tuesday session with regards to his implementation. So we're going to use that as a kickoff.
Cool. Morning, everyone. So from the questions that I got on Tuesday and in between, I just want to put out there that today's session is yes, it has there is a TymeBank context, but I've tried to take out infrastructure as code as much as possible so that I can share as much as possible. But I'll go on some of the questions on Tuesday. It was a lot of it revolved around AWS specific, or what platform we use. And just right off the bat, I think regardless of what cloud platform you use or what tool you're using for infrastructure as code, just make use of infrastructure as code. It just start using it small. That's the big one. We eat the elephant in small chunks. And one of the other questions I got was it had to do with my comment on infrastructure as code being the latest and greatest. Obviously, for me, it is the greatest, but it's not so much the latest. It is CloudFormation's been around for about 10 years now, but because of the strides that have been made in the industry towards infrastructure as code, it's become a more user-friendly. It's become easier. One of the types of infrastructure as code, the imperative type, is just an API call. So you could call. I remember when I just started out, I was using Google Cloud Platform. And with GCP, you use the GCP CLI. If you're using the GCP CLI to create a virtual machine, you're using infrastructure as code. You're using imperative infrastructure as code. But you're doing one small piece. So you go to a language or you go to a platform like CloudFormation or a tool like Terraform, and you start using declarative infrastructure as code, that's when you can start playing around a lot more. But we've been using infrastructure as code for ages. We just didn't really have this name for it, or it wasn't the thing that it is now.
Now, I think, you know, you touched upon something there, that even if you use the command line features, you're essentially using infrastructure as code. But I think it is also important that you need some form of infrastructure knowledge. You not necessarily need to be an infrastructure expert. I think having that base understanding of what you're trying to build is a good start off point. And I think you've touched upon the GDP stuff, you know, you touched upon CloudFormation. But one of the things I want to get to as well is that there's almost like a best practice around developing these type of infrastructure as code. Now, you know, if we have to look at, you mentioned just starting out with a command line. Now, command line is very cool because it kind of gets the ball rolling, but to get that repeating over and over and over, you need to kind of start looking at scripting. You need to look at maybe some pipelines to implement that. Because I worked with you on some of the projects, the infrastructure as code projects, maybe you can just give the audience a view of what approach we took to actually get our CloudFormation into some form of pipeline and how we enforce certain rules.
Yeah, sure. So I guess we started with the simplest. I mean, you always need a virtual machine. If you want to WSO2, you're going to run it on a virtual machine. So we needed to create X virtual machines. So instead of defining 6 code blocks or defining an API call to create a virtual machine, we would put it in auto-scaling groups. And once we have auto-scaling groups, we need load balancers. And once you start configuring load balancers, you need target groups, and you need all of these. So the way we approached it was, at time, we wanted to fit into Tyme's CI/CD pipeline as much as possible. And because we were forced down that road, we couldn't, it was a bit, sorry, you mentioned the best practices earlier. One of the best practices of infrastructure as code is to layer your infrastructure as code. Do everything in one script. So we didn't need to create our networking interfaces or our subnets or VPCs, that type of thing. We didn't have to create that at time. We needed to understand how it worked, so we started off by doing it ourselves in a different account. And once we knew how to do it, cool, we could then refer to Tyme's VPCs, which is your virtual private cloud. We could refer to Tyme's subnets and their security groups that they had set up before. So a lot of our environmental constraints helped us navigate how we should do infrastructure as code. I don't know if that's...
No, I think it does, and I think it comes by, like you said, layering and having a pipeline to actually manage that layering. When we set out to do this project, we had a look at the entire infrastructure stack, not just WSO2. So we looked at creating databases, creating VMs, getting the products deployed on there. So having that whole pipeline from an authorization point of view, and let me tell you, some of the guys there are fantastic pipeline guys. They understand how CI/CD works to a T. So we had pipelines that you would fill in a little form, and then that pipeline would automatically go generate your infrastructure as code pipelines and get all that stuff sorted and set up for you. So, we were very fortunate. But
and the best thing about that is, and that's something I mentioned on Tuesday, but everyone agreed on that pipeline. So, our line managers agreed on it. So when you're going to your line manager and you're saying, I want to do a deployment, they're much more open to it. Instead of saying, oh, where's your change request? Where's this? Where's that? Okay, you're doing it through the pipeline. We've all agreed on the pipeline and the security and everything involved. So, all right, just deploy to the sandbox environment was the first step in the CI/CD pipeline. Let's see what it does, and we take it from there. But it gives everyone a little bit more comfort.
Yeah. So I know that you've prepared a demo for today. So I just want to let the audience know that we do have something to show, and maybe Gino, you can start just sharing your VS Code. Let's look at the sample that you've prepared, and because there's some interesting topics when people start seeing what infrastructure as code really is. I think a lot of people confuse sometimes infrastructure as code with configuration management and automation. So something like using a Puppet, you kind of need existing infrastructure in place. So what we're talking about is the layer even below that, to say, well, what are my hardware needs and how can I get it in a standard repeatable format so that I know I can move this thing from dev to prod to a different data center, to a different region, scale up, scale down from an infrastructure point of view. Gino, I think just share the entire screen, not just the VS Code, if possible, because you've got the little boxes hovering over the VS Code.
Sorry, can you see it better now?
Yeah, we can see it a little bit better. So I think what you guys can see here is Gino's YAML file. Gino, maybe you can just walk us through what this YAML file will actually do.
Cool. So with CloudFormation, you separate your CloudFormation out into 3 main sections, or 4 main sections actually. I didn't show one of them here. The resources, outputs, and parameters. So the other one is mappings, of course. But resources is where we're going to be defining our what we're going to be creating. Parameters are existing resources or variables that we want to use in our CloudFormation script. And then outputs is specific things that we want to see come out of this CloudFormation script. And most of the time we're going to use it to output a URL. So if we've got a web server, the URL that you're going to access the web server with, that's the time what we're going to be outputting. So in our demo, I did it very much the same way that we did it in our, or at Time, was I started with virtual machines. So we've got a launch configuration, we've got an auto scaling group, we've got a load balancer, and everything that goes together with load balancers. So target groups, listeners, and Route 53s, etc.
So I think just to add, you mentioned auto scaling group, and we're going to start looking at a few things specifically to auto scaling. But just for the team to understand what that is, it's essentially just it's a set of VMs. So you define your VM, its pattern, its configuration, and as need be, you could just say scale this thing to 3 to 5 to 6 to 7 nodes, and it will essentially just repeat what's on that single box onto copies of it. And so you can set your parameters to, for instance, whether it be CPU usage, whether it be a date. We're gonna look at some other situations where you could essentially switch off your infrastructure in the evening and then almost be reassured that it comes back on in the morning. So maybe you can just show us a little bit on the auto scaling group. Well, I think even before we go to that, sorry for that. One of the questions that I just remembered from Tuesday's chat is somebody asked the question, well, where do you write your infrastructure as code? Where do you write your CloudFormation? So we do use VS Code, but do you mind just maybe showing the guys the online editor as well, and what benefits you get from that?
Sure. Let me just share the right screen.
Now, this is a cool feature because it allows, as Gino will take you guys through this, it does some nifty diagramming, and does some validation, things like that. That's pretty cool.
Are you able to see my browser?
Yeah, we are.
So I'm going to just create a new stack. Most of the time, you're going to want to host your CloudFormation templates in S3. You can just refer to your templates, the URL where it's hosted. But
maybe you can just tell the guys what is S3.
So S3 is Amazon's cloud storage. It's what it's called now, the exact name for it. But yeah, it's what's called a blob storage. So it's just a place to dump your files in.
Amazon's simple storage solution.
That's it. That's it. Right, so I'm going to upload our YAML file. One of the things I didn't mention before, let me switch my screen. Sorry. Are you able to see my VS Code?
Yes.
One of the main reasons that we use YAML, so with CloudFormation, you can use JSON or you can use YAML. YAML, even though it's a finicky language with indents and that sort of thing. A big thing you get from YAML is being able to comment. And that's something that you can't do in JSON. So I prefer to use YAML, but if you're the type of person that likes JSON, then yeah, go for it.
Well, there's another alternative we're going to look at after all of this, where you could even do this in your native coding language, or whatever you feel comfortable with.
Yes. So can you see my browser?
Yep, we can.
Cool. So I'm going to upload the stack and I'm going to view it in our designer. I think this is what you wanted to see.
That's it. So I think the majority of IT guys are a little bit lazy, and that's what makes us good at our job. And for me, the fact that I can just write the code and have my diagram created for me, it's pretty cool, because now I can start adding that to my documentation or my Confluence pages. So that's pretty nifty. Now, you can, Gino, correct me if I'm wrong here, but you could then on the left, you can see all the resources. You can start dragging and dropping, and it starts creating your skeleton in CloudFormation. That's correct, eh?
Yep. Yep. So you could do something like that, and then here it is in text, and you can start playing around and editing it over there at the bottom.
Okay, awesome. I think what we can start doing is, let's execute this CloudFormation, and we can show the resources actually, you know, starting up and starting to connect and deploy. And when I think while we do this, then we can just quickly touch upon the Terraform topic.
Yeah, sure. So I've done that. I just want to, I think before we go there, I just want to show when we're creating CloudFormation stacks. So I mentioned all the things that we were going to be creating, and I just want to take you through the process of creating a VM in or a sample of the process of creating a virtual machine in Amazon. So it might look simple, but if you're doing this over and over, it takes time. So we're going to launch an instance, and there are 6 steps for you to go and configure a whole bunch of things, where it's click, click, click all the way through, but those clicks become quite a lot, and that's just for the one virtual machine. Where in CloudFormation, we're doing that and we're making it repeatable, but we're creating a whole lot more as well, which takes a lot of time to go through each and every resource and configure it manually.
And you know what? A good thing there is, because a lot of companies are now starting, yeah, in South Africa specifically, are starting to adopt cloud more and more. I think they don't really understand the cost behind a lot of the choices they make. For instance, just looking at an EC2 instance, you've got so many different subtypes, whether it be performance-based, whether it be a storage-based, and all of those have a cost impact. So if you've got a development team who needs to spin up their infrastructure, you could end up with infrastructure that costs you way more than what it actually should. And we made that mistake in the beginning when we did the lift and shift. We chose the wrong EC2 instances, and what we realized very quickly is some of them have got processing thresholds, and once you've reached a threshold, your out of bundle rate, if I can call it that, is quite expensive. So by defining some form of skeleton, you can ensure that the entire stack is of 100% the same sort of OSs, the same sort of processing, all of those things.
Yeah. Cool. So just some of the things that I wanted to show you is those parameters that we defined in our YAML file. They're all coming up. So we give them a default value, And all of those parameters are coming up here now. I give them default values because when you're going through a pipeline, you won't see this screen to create a CloudFormation stack. Your pipeline is going to create it for you, and your pipeline uses those default values. So here you can see the default values defined. One of the things that you can do is you can give parameters allowed values. So under the instance types, I've given them specific instances that you can use. So if you've got a defined stack, and what Jonathan just mentioned now with us using the wrong instance types, you can define a stack and have allowed values. So you can prevent developers from using the wrong things.
Yeah, I think choosing the right VMs from the get-go. I think when people work out, what is my operational cost? Let's say, for instance, WSO2. I want to install WSO2. They look at, okay, well, this is an open source project, or if they want to sign up for licenses or subscription, they look at the licensing cost, but they don't always think about, well, did I choose the right instance? Because my infrastructure could, at the end of the day, cost more than my licensing fees. And by looking at the operational costs from that level, and from a database point of view, which databases do I use in the cloud specifically? A good example is if you use MySQL. If you run an EC2 instance, you manually install MySQL and you connect to it. It is a lot more expensive than just using the AWS database services.
Yep. Yeah, and the more you get to play with, the more you can run quite a large bill. So so on this step, we're just giving our stack a name, and we're defining or we're setting those parameters that we wanted to set. Here we can give it some tags, and we can give it a specific identity and access management role that we want it to use when it executes. This becomes, for the demo, it's not important, but this becomes important when you're in a large organization and you've got quite a few different teams. Some teams, you don't want them to necessarily have a programmatical role that can create or delete security groups. But other teams, you need them to have that role. So you would allow certain roles on certain CloudFormation stacks. So let's go next, and I'm going to create the stack. So this screen that we get here is where we're going to see every event. There won't be many for this one, but it's going to start creating those resources that we told it to create, and those resources will come up here, and you can see their IDs once they've been created. Events will also, if this fails, it'll give you an error on the specific resource that it tried to create, if it wasn't able to create that resource. And what's nice is it'll give you a reason here as to why it couldn't create that specific resource.
Yeah, I think it's also just for the attendees, we're showing AWS because that's what we used at time. But I think the base principles is you can take that to any of the other cloud providers. We went with CloudFormation specifically because we tried to, the mandate was to go AWS native as possible. But Jamith mentioned on Tuesday where organizations are opting for a multi-cloud strategy. Now, if you think about it, the work that you've put in to do a CloudFormation script, you can't just transfer that over to a GCP or Azure. So to while this thing's creating, and we've got another demo, so we're going to delete this stack. But while this is creating, we've got something similar that we've done, of what that Gino has done with Terraform. So just to give the guys a little bit of a introduction to Terraform. Terraform is essentially doing what you're seeing here in front of you, but with multiple cloud platforms, as well as supporting a lot of the on-premises VM technology. So it allows you to essentially define the same logic or the same rule sets or the same parameters, and it then would go to your desired platform and then create your infrastructure according to your spec. So I think what Gino's going to do after this, he's just going to show you guys how it works, but then we're going to start looking at Terraform, because Terraform becomes very exciting if you start comparing it, or not comparing it, combining it with some configuration management like Ansible, where you could essentially trigger certain functions within Terraform or within CloudFormation. A good example would be if I attended one of the Ansible workshops, and we saw one of the guys use, or one of the companies actually use Ansible to enforce throttling in ISPs. You know, when a certain criteria gets reached, then Ansible goes and updates a bunch of configurations in multiple countries. So you could have certain rules where it would trigger your AWS CloudFormation scripts, or it would trigger your Terraform to say, you know, that auto scaling group that you have that's running WSO2, well, during 9 in the evening to 6 in the morning, we're not open. We don't expect traffic. So go set that scaling group to 0, so that I don't actually get a bill for that. But I think I just want to remind the audience that, you know, as we're going along, please, if you want to join the conversation, let me know. I've got the power here to click allow to talk, or you can send an anonymous question. This is as much your conversation as it is ours. Sorry, Gino, you can carry on there.
No worries. So the our stack has been completed. If we go to outputs, here is our output URL, and I've specified the wrong URL, but I'm going to use a nice DNS now. I think this might work anyway. It just won't have SSL. Yep. Cool. So WSO2 is not running on our EC2 instance yet. So even though the load balancer is available, the instance behind, or the VM behind the load balancer, WSO2, there's a health check on that we define on WSO2's ports. And those ports haven't come up yet, so we know WSO2 is not there. That just also highlights something else I want to show, or that I'm not showing in this demo. But with all of these auto scaling groups, or with CloudFormation, you can have creation policies, and you can have creation signals. So you could have CloudFormation wait for a signal, a predefined signal that you've set in WSO2 startup script, for instance. So right at the bottom, once WSO2 started up, it must send a signal to CloudFormation saying, "I'm ready, and I'm waiting for traffic." Only then will CloudFormation change the status of this resource to create complete. So that's, you shouldn't just rely on just creating things in CloudFormation. It is intuitive, but sometimes you do need to tell it that a specific resource depends on another resource, or wait for signals before you carry on. It can help you when you combine your application with your infrastructure like we've done here. So let's see if it's up again. Okay, still some time. Cool. So while we're waiting for that, these ARNs that we have here, every resource in AWS has got a specific ID or number associated with it. So ARN, I think, stands for AWS resource number.
Gino, we've got a question here. So it has to do with scaling. So you mentioned that the auto scaling can happen, automatically. So the question is, how would you scale automatically, and what parameters can you set to actually define those? So essentially, this user just wants to know how we can scale up or down, and what parameters can we use to dictate that.
Cool. So as far as I know, a auto scaling group is specifically for horizontal scaling. So we're not going to be adding more CPU or memory or changing instance types. With auto scaling groups, we're just going to create more instances. So one of our auto scaling, if I go into our auto scaling group here, we can then set what our desired capacity is, minimum capacity and maximum capacity. We set that in our CloudFormation script. Now I just want to find the scaling policies. So you can use schedules to scale, so if you know that at a specific time or on a specific day at a specific time, you're going to be expecting more traffic, you can create schedules here. So we used scheduled actions in our dev environment and our sandbox environment to save on costs. So what we do is we create a schedule and we say between 6 in the evening and 6 in the morning, scale into 0 instances. So we've got nothing running when no one's working. And then every morning at 6 in the evening, we'll have no instances. And then in the morning, it'll bring it back up to 1 instance. So you can save cost in your sandbox or your develop environments like that.
Sorry, Gino, I just want to mention now, I think there's some people who listen to that and they think to themselves, well, you know what, we're not in the cloud. So why does this really benefit us? Well, that's where infrastructure as code is not just specifically for the cloud. If you use something like a Terraform, Terraform supports VMware Cloud. It supports, I've got the whole list here up in front of me, and it even, you could use this for your on-prem environment. So you could, if you had an infrastructure team that were open-minded and allowed you keys to their treasure chest, then you could get similar style of performance with on-prem rack solutions.
Yeah. Yeah, so using the configuration tools or orchestration tools like Ansible, Puppet, Chef, yeah, you can 100% do the same sort of thing on-prem. You could even, you can do it in the cloud as well. I mentioned earlier, but CloudFormation, not CloudFormation, AWS has got a few metrics by default that you can use to scale. So you can tell your auto scaling groups, I can't find them right now, where we've actually got, oh yeah, scaling policy. So you can have CloudFormation alarms. So, CloudWatch alarms. And CloudWatch alarms are quite nice. Any metric on a virtual machine, so memory, a CPU, you could do hard disk space, anything. You could even have your application create CloudWatch alarms, where once that alarm goes off, you could have a scaling policy based on that CloudWatch alarm, and if that alarm gets triggered, it will scale. So you can add X amount of capacity, or you can remove, or you can set to. So the question on what can you use to scale, or how do you scale? The answer is pretty much anything. Anything that you can define, because of AWS's CloudWatch and the alarms and what it monitors. And that was very important for us at Time as well. We wanted to have as much visibility as possible in our stacks, where we had with the API Manager Analytics, we had how our APIs were being called, but when we wanted some of our metrics on our instances, CloudWatch became the answer for us, as well as our centralized logging, where we just shipped all the logs to CloudWatch.
I think, so what auto-scaling helps you to do, it's, like you said, the horizontal scaling, but because we've got infrastructure as code running, and with certain certain parameters being set, like a rolling update and things like this, even legacy systems that don't have clustering in mind, if you had to scale vertically, you could do that in your CloudFormation as well by updating certain parameters and just rerunning your pipelines.
Yeah. So some of our log groups that we created were these, the ones you see in front of you, where every instance that comes up, it's got its own instance ID, and we've told those CloudWatch to monitor the WSO2 carbon log file. Don't think this is on right now. No, this is not happening right now. It's not part of our demo, but it was just to show you more or less what you can do with CloudWatch and with AWS. Now
this is very similar than what you would get in the Elk stack. So it essentially, it's got an agent that ships your log files to a storage unit, and then this is just rendering the logs. But what you can actually do here is you can also write your queries, and you can do some dashboarding around this. So you can even there's even some attachments. I got delivered a nice cup of tea. Thanks to my wife there. So yeah, you can essentially have Kibana also point to the CloudWatch database, and you could then start reusing your dashboards in that manner as well. So if you've got a hybrid style environment, you can start consolidating your on-prem Elk stack to maybe your CloudWatch, and have those two data buckets render the same dashboard. Yeah. Cool.
Yeah, I mean, it just helps you with insights. You can pinpoint what's happening, and the important part is you want to see what's happening in your system before your consumers see what's happening in your system, before they start feeling the problems in your system. You want to fix.
I think it became a real always a blessing in disguise almost for us. But we set out to say, well, we're not a very large organization. We don't. I think Gino, correct me if I'm wrong, but I think our dev team is probably 80 people around there. So transparency is key, and utilizing certain standards like, we don't have super sensitive data in our logs, so we will ship all of our logs to a central place and everyone can start helping when something goes wrong. Having auto scale groups, having pipelines, having cloud formation in a standard format, you know, we can actually, we can start leveraging off of each other's work. We actually have a question there in terms of.
So one of the, something I just wanted to showcase as well. I've been playing around last night. I was playing around with these demos as well. And I've got a listener on my load balancer that accepts traffic on your default SSL port, port 443, and ships it off to 9443, which for W2, that's the NIO port, I think. So I've got another listener. I should have another listener at 9443. So what's nice about this is I can go into my CloudFormation, see, all right, let me go. Okay, I've got two listeners, 9443 and 443. Great. Shouldn't have one for 9443 because we want to hide that specific port. So I just remove it and save and commit. In the optimal case here is I would commit this to a Git repository and it will automatically build, it will automatically update my CloudFormation script and remove just that listener. So if I save this and I come to CloudFormation, let me update, replace the current template. So this is from the front end, how you would do it. And it's not too bad, but you want to prevent people from just coming to the front end and making changes willy-nilly. You want it to be going through version control. So yeah.
So Gino, while these changes roll out to your deployment, we've got a question here that basically asks, you know, in terms of the WSO2 products, how do you deal with things like well-known addresses with clustering? So WSO2 specific, you know, in some of the products, if you want coordination between the units in the cluster or the nodes in the cluster, you need to make them discoverable with tools like Hazelcast and something like that. Maybe you can just tell the guys how we dealt with that in AWS specific, and then we can. Sure. I'll just carry on how we solved that in Kubernetes.
Awesome. I don't have a specific file to show you now, but WSO2 has got membership schemes. It makes use of Hazelcast, and it's got different membership schemes. The default one that we use is well-known hosts. So you will tell every node in a cluster, you will tell it what the other nodes in the cluster should be, and you'll specify their IP addresses. And that becomes really difficult, if not impossible, to do with scaling, because you're constantly going to have new IPs. When you scale out to 2 nodes, for instance, or 2 virtual machines, you might have your initial one and you've specified its IP. You scale out, here's another IP for you to go and add. When you scale back in, you don't know which IP is going to be removed from the group. So there's a lot of, there is a way that you can do it, but it's extremely complicated with lambdas and all sorts of cool things like that. But WSO2 also makes use of the other membership scheme they have is the AWS membership scheme, which it's quite nifty the way it works. I just want to go to EC2 here. So in AWS, tagging is very important. I think in everything, tagging is very important. If you ask my mother-in-law, tagging everything in the house is very important as well. So if we have a look at the tags we have here on one of our instances, here's some default tags that we've set, that CloudFormation sets, and we set a name tag. So for the AWS membership scheme, it will create a cluster tag, give it a specific value that you set out. So you could say, for API manager, I'm going to have a value of APIM. Every instance that gets created will then have that tag. As it scales, it'll have that tag cluster and APIM. And Hazelcast, with the AWS membership scheme, goes and looks for any instance with those tags and adds it into the cluster automatically. So that's how we did it with AWS.
Yeah, so what they've done is they've essentially, WSO2 has written a bunch of additional jars and they've built that into the product. So if you state AWS membership scheme, it can dynamically, using something similar to service discovery, actually discover which nodes are up and running and which are associated to a specific group, and then dynamically set that as it scales up and down. So again, same user. If the customer does not use AWS, how could they achieve this on Azure and GCP? Geez, you guys are asking the tough questions. So I'll have to look. I think that would have been nice to have Chimithia on that one. But there, as far as I know, there's no, in GCP specifically, there's no current WSO2 supported membership scheme. So the AWS jars will most probably have to be converted specifically to utilize the Google internal API. So that's quite a bit of work. What we almost would suggest in that stage is, start looking at things like Kubernetes, because Kubernetes is essentially the same in all clouds. And one of the other membership schemes that Hazelcast supports is the Kubernetes one. So that just allows you to go in any cloud environment and have this auto elastic scaling integration environment add to the membership scheme. But yeah, to be honest, I don't know how you would do that in GCP and Azure from an automatic point of view. You would have to do a lot of fancy tricks and you would have to do restarts. And I think that's the downfall with regards to Hazelcast as a clustering mechanism. But I think, correct me if I'm wrong, Gino, but I think the WSO2 is actually considering moving away from Hazelcast and using other clustering applications, and specifically for this reason. So WSO2 was always traditionally for on-premises, and as they are focusing on being more cloud native, more flexible, and adapting into that environment as well, they had a look at Hazelcast and they've realized it's just too limiting.
Yeah. Yeah, so it becomes a little bit complicated if you had to use, I think the other way to do it is polling the databases. And it becomes a little bit complicated with, you can set your database polling to a very, in the API manager, for instance, the main reason why you'd want Hazelcast or clustering in the API manager is to revoke tokens on every single node at the same time. So if you're polling a database and you're polling it every 5 seconds, if you revoke a token on one node, it's going to take about 5 seconds for all the other nodes to catch up and say, well, that token's been revoked. Sorry, not just revoking tokens, but for throttling policies as well. So if you've got multiple gateways and a user's hit their throttling policy, they could still make some more calls within that 5 seconds. You're polling every 5 seconds, but you can decrease that polling interval. That it's a few more complications with your databases and amounts of connections going to your databases, but you can solve it. It's just quite a little bit of, or quite a few workarounds.
Yeah, good catch there. So the other clustering mechanism that you can use if you don't want to use Hazelcast is database clustering. But we've picked up some issues in the past, to be honest. But it can be done, I think. To be honest, and I think this is where we've recently done a few projects like that now as well, and we most probably will be moving at time to that deployment style as well. But if you would have told me right now to redesign that infrastructure, I think I would have gone with a Kubernetes containers deployment, just because of the flexibility where I can then use the same. Just to give you guys an example, we use Hazelcast, a Helm, to deploy our Kubernetes artifacts. So that's just another form of a deployment tool. So if you have Helm installed with a solid definition of your WSO2 environment, you could now easily migrate that to multiple cloud environments and not have to worry about things like clustering and how can I say, repeatability of your infrastructure. Gino, maybe we can just quickly show the guys. I know we're running a bit late and we can carry on for hours. But maybe let's just quickly touch upon Terraform, because I know you've got a pretty cool demo on that as well.
Sure. Just to show you that we updated our CloudFormation stack, and what's cool about CloudFormation is it will only update the resource that we changed. So if I go to, if I try and access our API manager through 9443 now, it shouldn't work. Let's see. Yeah. Yep. So now we've played around with our stack in CloudFormation, and we've seen everything that we need to see, and we've created all those resources. Now it's as simple as clicking delete, and we no more have our stack. So
sorry, Gino, one more thing before we move to Terraform. I know I'm butting in here, but the cool thing about having all of this in a repository like we've got it running now is when your infrastructure changes, and you know that the only way that you can get infrastructure or you can get your hands into the environment is through a pipeline. It becomes very easy to roll back to a state that previously worked, or have some form of accountability. If now, let's say for instance, this is a good example. Now suddenly the port is not available. You could easily go check, what happened in Git. Let's go look at the changes from an infrastructure as code point of view, identify the problem and roll back those changes, where if in a traditional deployment manner, it would be quite a big, almost witch hunt to try and find who changed what, where. I have to go through all of these network devices manually to just try and find the issues.
Yeah. Cool. So before we go into Terraform, I'm just going to kick off the Terraform script. So while we talk about it, it's available. So yeah, Terraform is a different infrastructure as code language, like we've mentioned before. It uses, it's part of the HashiCorp stack. It uses its own language called HCL, or HashiCorp configuration language. That's very similar to JSON. But everything we did in CloudFormation, we've basically done in Terraform over here. So I've created a whole bunch of variables in Terraform, and those variables are the same as our parameters in CloudFormation, and then our resources exactly the same as well, not exactly the same, but our resources are the same as the resources we've defined in CloudFormation. but I don't know, for me, the Terraform just has a nicer way of defining or referencing certain objects. So where CloudFormation is quite easy, if I want to reference a target group, for instance, it's as simple in CloudFormation as doing a ref and then specifying that target group. But Terraform, it's quite long-winded, but it gives you a lot more. So if I want to reference a target group, I'm going to specify that it's an AWS target group. It's the resource that I've created, and I want its ARN. Or I could specify that I want its name. I can get a lot more from it, where with CloudFormation, just using ref, it's going to return a specific value. So Terraform, the one thing I missed was your providers. You're going to set right at the top. So we set AWS as a provider. I've got multiple profiles or accounts in AWS. So I specify the account and I specify the region that I'm in. The region is very important to specify the right region for two things, mainly for cost. And then number two, for your own sanity. There's been a few who have created resources in Ohio, and I'm looking for them in Dublin. And I don't know why with my Terraform or CloudFormation, it's run, it's successful, why the resource is not there.
And that's one thing that no cloud provider actually just gives you, is to say, well, just show me everything I have in all regions, and it becomes quite a nightmare.
Yeah, exactly.
I just want to comment, Gino, there on your provider. So there you've got AWS. So just to think, Terraform has got, I think it's more than 200 providers. So that would include things like Rancher, it would include things like Kubernetes, your VMwares, all your cloud providers. So it is pretty powerful if you're looking at a multi-cloud deployment, or you're looking to introduce some form of infrastructure as code on an on-prem environment. You're not sure yet where you want to go. Rather invest the time into something like a Terraform rather than invest time into a cloud provider that your organization might not even move to.
For sure, yeah. I think it's important to try all of them, but a good staple is Terraform for those reasons. If you're going into hybrid cloud, which a lot of people are a lot of companies are moving towards hybrid cloud, if you're doing something like that, then Terraform's the way to go, because they've even got providers for VMware and what's the other one? I forget now, but
Oracle.
Yes. So yeah, Terraform, it's quite simple to learn, and it's extremely powerful. But I do encourage you to try all of them.
Gino, correct me if I'm wrong, but I think even one of the AWS architects or developers that actually work for AWS, they even fans of Terraform.
Yeah, they a lot of AWS engineers do prefer using Terraform, and a lot of them. Again, infrastructure as code, it's about ease. So if using Terraform is easier for you and for your organization, then use Terraform. If using CloudFormation is easier for you and your organization, then use CloudFormation. If your time, we sort of, we're an AWS partner. So there's no way that we're going to be using something else in the near future. So let's use CloudFormation. Using Terraform doesn't really give us much benefit at time.
And I think it's also just important to from a performance point of view, what you guys see here is Terraform's own mockup language. So what it doesn't take this, convert it into CloudFormation, and then actually executes it. It executes all of these steps natively. So that becomes very powerful in the sense that if AWS now, for instance, goes and updates the CloudFormation spec or definitions or something like that, your Terraform scripts will still be able to work because it integrates directly with the cloud platform.
Yeah, yeah. And that's one thing that you'll see now. So Terraform's still busy creating that sort of thing. So I've shown you Terraform. What I like a lot about it as well is having multiple files that you can see in a repository. So if you wanted to specify a key that you wanted to create just for a specific reason, you could have the key, SSH key, in the same directory. You can have multiple files in the same directory. And like I'm using a user data bash script. So when the EC2 instances start up, they must execute this bash script, and I'm just putting that in the same folder. Where CloudFormation, I had to specify it as text in the CloudFormation file itself. So I prefer to have things a little bit separated out.
And one of the big things that we saw as well, just to speed things up, now that Gino showed that snippet of code, is he touched on Tuesday. He touched upon the images, the AMIs, is to create an image and start from there rather than trying to download the product every single time when you spin up a new instance. Just maybe we can just I can see the participants list here. And you've got the functionality to raise your hand. I just want to see, is anyone in the audience currently looking at either migrating to cloud or looking at a strategy for infrastructure as code? Just a quick hand if there is anyone. Because what we can then do is we can actually maybe tailor the conversation more to your cloud provider or your specific use case. If not, we're just going to carry on. I'll keep monitoring it. If you do get your guts, then just raise it. Cool, Gino. Sorry, carry on.
Cool. So our Terraform script does the same thing as what's going to create the same resources as CloudFormation. And here we can see, I'll go right from the top. When we told Terraform, so when we're in that directory where our Terraform files are located, we just say Terraform apply. And here it's telling you what it's going to do. So it's going to create an auto scaling group, launch configuration, load balancer, all of that cool stuff. And it asks you, do you agree to it? You say yes, and there it goes through and creates everything. If I go to CloudFormation now, our stack did delete, and you'll see there's no stack here. So like Jonathan mentioned earlier, Terraform doesn't create a CloudFormation stack. It uses the native API calls to AWS, and it creates the resources in that way. But if I go to EC2, so one of my instances is running. There we go, there's my running instance. And let's go to auto scaling groups. I've got my auto scaling groups. So Terraform does tag automatically. If you do forget some tags, it'll name the resources, give them its own names. And let's see if WSO2 has started running yet.
Yeah, it would have been nice to be able to show the audience the actual implementation we have at Time and show that scale up and scale down, because it's pretty cool to see once you've got all the pipelines and things in place.
Yes. Just want to check. So my Terraform script only has 9443 as a listener, so it's not going to work on 443. And there we go.
Awesome.
So our Terraform script worked, and we're quite happy with what we achieved with Terraform. So now it's as simple as we're done. So we say, can I kill it, Jonathan?
I think just before you kill it,
Cool.
we've got a question here that says maybe you can just expand a little bit on the infrastructure drift detection, what that is, and how do you do it in both of the technologies?
So I personally, I haven't worked much with Terraform's drift detection. I'll show you how to do it now. But in CloudFormation, if we go to our stacks here, so it has, where's CloudFormation? I can't find it now. Oh yes, here we go. So drift status is not checked. So you're going to have to get CloudWatch to monitor your stack, and then whenever something changes, it will notify you that you've had drift in your CloudFormation stack, and you can go in and see what has changed. With Terraform, you have Terraform refresh, I think it is.
So Gino, I think just so that the audience, because we're about to wrap up, I think just to let the audience know what is the drift detection.
So if a resource has been changed from the front end, you'll be able to see how it's changed. Or for instance, in a auto scaling group, if you've needed to scale above a certain number of instances, or let's say you've set your desired capacity to 1 and you're sitting at 2, that is drift. So you're going to have you can then see that you actually need 2 instances instead of 1, because it's constantly sitting at 2 instances.
So there is a question with regards to drift, specifically handling configuration drift. So where you've modified, if I can just quickly see there, let's say one machine has got a hot fix and the other one doesn't. Drift detection is more with regards to infrastructure scale, hard drive space, CPU, things like that. Is there a way to actually handle drift configuration or drift detection on config files, or that's all just depending on your pipeline and managing that in your repositories, eh?
Yeah, that you'd have to manage yourself.
So this is purely on an infrastructure level, not a configuration.
Yeah. So when you do, if you're doing this through a pipeline with code commit is AWS's source control. When you do a pull request, you can obviously see what has changed since so you that has to approve the pull request, you can see what has been changed, and then you can approve it. Or that's a way of checking it, and then you can just go and have a look at commit histories. I'm sure there would be a tool that you could use to.
A good example where that would work is, let's say you've got a cluster of API managers and one of the nodes is running out of hard drive space, and you manually go increase that hard drive space over and over and over. What drift detection will actually do is it will tell you, listen, out of your whole cluster, you have modified this one's hard drive space over and over and over. You need to address it. Either update the entire cluster or see why that specifically is happening on that one node. But from a configuration point of view, I think that's why a pipeline is so important, so that you get that level of consistency, but you still have to follow best practices of rolling it back. So if you want to do hot fixes, check it in as a hot fix on your pipeline and allow the tooling to do a rolling update to manage those changes. But we all know that it's easier said than done.
Yeah. So with Terraform, you can, at any point in time, you can have a look at what's been deployed, or every resource's IDs and where every resource has been deployed, and anytime the same with CloudFormation. And then if something has changed in AWS, you can use Terraform refresh, which will refresh your state file for your for Terraform.
Cool. I think that's a good point to end. Gino, do you have any closing remarks that maybe, I think, let me pose the question rather. If I gave you the mandate and I told you, I don't care what cloud provider you use, please install WSO2 on that cloud provider, more or less what approach would you take? Would you go pipeline? Would you go infrastructure as code? Which cloud providers would you choose? Which infrastructure as code would you choose?
So I'd obviously choose AWS because it is what I'm used to as a cloud provider, but I don't think it makes much of a difference who you choose. As long as it fits your organization's model, and as long as you're comfortable with it, then fine. The same thing with infrastructure as code. The platforms we showcase, you obviously can't use CloudFormation in Azure or GCP, but they have their own tools for that. I would focus, or I would personally use Terraform as a infrastructure as code platform, because it just opens me up to more providers.
I just also want to tell the audience, if you spoke to Gino probably 2 months ago or 3 months ago, he probably would have thrown Azure in there. So you know,
yes.
As this arms race is continuously happening in clouds, organizations struggle to identify where they need to go and where they need to invest their time and money, because it is such a permanent move. You know, if you had to ask me, okay, so there's another question. I'll get to that now. So if you would ask me, I would go AWS or Azure. I would also go Terraform, and I'd go pipeline from the beginning. Whether that be, I'll definitely go container-based WSO2 deployment using Terraform to manage that in those two cloud environments. Gino, we've got a question here on Terraform. What happens if you delete Terraform state file? For example, if you remove AWS instance from the state, will AWS instance continue running? So I think that's that question, and we can, whoever that is, if you want to join the conversation, we can enable your mic and we can have a conversation about that. But I think it's if you have the instances running and you manually go and delete it.
Yeah, so manually go and delete it. You'll need to do the Terraform refresh so that you can see the difference, what's in the cloud and what's or what is on your what is in your state file. If you delete your state file, I don't know. I'm pretty sure there's a way to get it. Let me just have a look here. I think I'm quite sure there's a way to get it. But I think if you do Terraform refresh anyway, whether you have a state file or not, you should be able to pull that what's in the cloud. I think
a good answer to that is don't delete your state file.
Don't give your users privileges to delete files, or
put your state file in a Git repository.
Yeah.
Okay, if there's no questions, Gino, do you have any closing statements?
Yeah, so the one thing that we didn't get to go through here was for AWS specific is the AWS CDK. And that is just coding CloudFormation in the language of your choice. So a quick one, Python, I've got a little Lambda function that gets deployed here with some Python code. And what the CDK does is it will convert your Python code into CloudFormation, or your Java code or your JavaScript code. It'll convert it into a CloudFormation template and deploy it into Terraform, into AWS.
Yeah, so your developer not just codes the logic, but also in the same language codes the infrastructure.
Yes. So I'd encourage you to go have a look at that as well.
Awesome. Yeah, so from my side, just to wrap up, because we haven't had another question yet, I just want to thank Steve and the guys from the ARCs and WSO2 for giving us this opportunity, because we can just ramble on and on and on. And I think for you guys who don't know, Gino is leaving the ARCs family. So we just want to thank him very much for his time, and working on this project was awesome. He's actually moving to Canada, so we just wish him a lot of success abroad. Thanks, guys.
Thank you, everyone.
He's just moving to the Darks family in Canada. I don't know what you're talking about.
We're expanding. We're going international.
Exactly. We've given him his snow pick. I sent it to him the other day, so he's all sorted. Thanks, guys. So I just literally hot off the press. So a bit of sort of marketing from my side. I suppose you wouldn't expect anything less. But I'm just going to throw in a few hot off the press things on the marketing side. But before I do that, let me share my screen. I know some people joined later on. So for those that we hear from the beginning, apologies. Just going to have to wait for my marketing for a second. On the Darks website, if you just go to the events and move through to this 2020 integration series, all the episodes are made available over here. So if you've missed out, you can feel free to catch up over here. And then the next thing I wanted to do was the Forrester Wave report on API management came out yesterday. I think Paul gave us a sort of a blocked out preview in his presentation on Tuesday. But it's now been made publicly available. So this slide here, I just pulled up the 2018 one because I think what's significant as well, because I think a lot of people on the audience won't have seen the 2018 one. But this is just to give a sense of, can I say, trajectory, because I think that's important. So just sort of snapshot in your head the 2018 view. And then I'm going to transition across now to what came out today, which is 2019. I'm on the wrong tab here. A second. It's my way. I don't know if that's too small. Can you guys see that, Johnny?
Yeah, we can see it. It's fine.
Okay, cool. So this is today's. So this is on the WSO2 website. What I'll do is I'll make sure if you go to WSO2 site, you'll be able to navigate to it. I'll also make sure it's available on the Darks website. I think this was quite a cool quote. So out of the report, I'll just pause there for a second. Okay. And then I don't know how well your snapshot worked on the 2018 view, but I think awesome to see WSO2 now firmly embedded in that leadership, I can't use the word quadrant, but wave. And I think the trajectory is the point that I wanted to make. So that's my marketing. Over and done. Let's get back to. Oh my goodness, I've lost the plot here. Please excuse me. So that's it from our side. Just to say thank you to everybody that participated. Thank you to our presenters. I think we had awesome presentations throughout the series. Really what we're going to do now is start developing our thoughts around season 2, because that was always the idea. So as we consider where to from here, I think a lot of people have gotten a lot of value out of it. So hopefully targeting a sort of October timeframe, maybe October, November, we'll be looking to launch into season 2 around this and coming up with different topics. And if there's any input or commentary or feedback, things that we can improve on, the input would be most welcome. So with that, it's a goodbye from me, and have a good day.